Hi, folks. This is activity number 2 for week number 7. And you're asked to model this simply supported plate with the appropriate elements. And you see that, as soon as you see that, you should realize that at least in this course, at this stage of the semester, you should be using shell elements for this problem. And use as many planes of symmetry. Now, obviously, this is a very straightforward problem. All you need to do is to model 1/4 of this, and then use the appropriate restraints. Subject to 5 psi, this is pretty much nothing, but thickness of this guy is half an inch. 5 psi on that dimension pretty much is nothing as far as deflection goes and the stress. Now, uh, you can create quarter of this, or you can do the whole thing. That's entirely up to you. Let me do a quarter, okay? And let's go ahead here and start with because we're dealing with surfaces, so I'm gonna do it in wireframe and surface design. You have no choice. You can't do it in part design unless you decide to extract faces of some box, so or some geometry. So file, save management, save as. I'm going to go up to activity number 2. Okay, on that face, I will sketch. Let's see now, 20 by 20, that's 1/4 of the model. I'm going to dimension this. 20 inches. Ooh, big. Also 20 inches. Okay, exit. And you can fill it if you want. You could have drawn a line and then extruded it. That's entirely up to you. So I'm going to fill this thing. There we are. Okay. And let's put a material on this. Metal. I'm going to put steel on it. On my version of the program that I have here, when I try to change the properties by double clicking on steel and putting the appropriate numbers here, right? Uh, these numbers that could, my version crashes. That has to do with installation. Okay, good. So this is pretty much it. Now we're going to go to generative structure analysis. You can do it with that lousy three-noded element or a triangular element. But I mean, let me take you to advanced machine tool here. Do a nice rectangular or quadrilateral element, and there we are. Surface measure there. Okay, and then zap it. There we are. Let's see how big this thing is. So we have to exit and let's look at this. There we are. Oh God, it's an overkill. You can see that. Anything you don't like, you can actually hide. So for example, the part you don't like, oops, undo, undo. If you don't like the height, you can part it, or you can hide it and just see the mesh. Okay, the rest of the problem is straightforward. You go to generative structure analysis and then put a thickness on this. Already there is a mesh here. You can look at it if you want. Right click mesh visualization right there, deactivate it, and put a thickness on it, 2D property on that. Can't remember what was the thickness there. 0.5. Okay, so let's change this thing to 0.5. Good. Now let's hide the sketch here because that's going to cause us a problem. We can put restraint on the sketch. So let's go and look at the simple support here, right there. Don't clamp it, because if you clamp it, rotations are also fixed, and that's not a simply supported plane. So I'm going to go click on that. So this edge is that edge, okay, and simply supported. So simply supported means no translations. And as far as rotations goes, we know that there is no rotation about the x-axis because of the simple support, but I'm just going to leave the other ones alone. There may be no rotation in direction y and z because of the nature of the loading, but they're not fixed for sure. Okay, now this is in the plane of symmetry, so you look at that. This edge is in what plane of symmetry? It's in the XZ plane of symmetry, right? So no rotation about, no displacement in the y direction, no displacement in y direction, because in the, which one? I'm sorry, this edge lies in the YZ plane of symmetry, therefore no translation in X, and rotations opposite. Yep. The other edge, that edge, lies in the XZ plane of symmetry, no displacement in Y, rotations opposite, and that's pretty much it. As far as the load goes, pressure goes on that face, 5 psi, is that right? 5 psi, that's nothing. Atmospheric pressure is uh, 14, I think it's 14 psi. Yeah, that's right. Let me take that pressure and change it. It's ridiculous. How about 50 psi? Even that is nothing. But okay, so yeah, pretty much it. So let's run it. The one thing is, one thing you want to check. I'm going to do that later. Let's see the direction of that. See that? I wanted to push down on it, so this is not correct. Double click with a minus sign here, because I wanted to push it down. Although, as a problem is simply supported plate, it really doesn't matter whether you push it up, you push it down. But that's how I want to do that. I wanted to make look like the geometry that I have my problem. Okay, so good. Let's look at the average ISO material shading. It looks like that. What is this actually? This is the one meso stress. Pretty much nothing. Because remember, the yield strength for steel is roughly uh, 300,000 psi. The Young's modulus is 30 million. So you knock down three zeros roughly, and you're going to get 300,000, I believe. Yeah, 300,000 psi. Yeah. Now, if you want to look at the deflection, very tiny. Ooh, okay. So let's actually figure out what's going on here. We had a geometry which was, okay, 20 by 20. Well, the original plate was 40 by 40. And so that's 1600, that's 600 psi times 50 pound per square inch. So that is actually 80, let me see, 80,000 pounds. 80,000 pounds. So if we knock down uh, 80,000 pounds divided by 2, that's 40,000 kilogram force. That's 4 tons actually. But remember, this is a plate which is half an inch thick, 20. So it is rather thick plate. However, this 5 inches is also not very realistic. I mean, if a 40-inch by 40-inch plate uh, bent so that in the middle point I had 5 inches, it'll probably yield. So that's a gigantic load, and I had to eat my words because I thought that this was not a big deflection. Let's look at the stress one more time. Stress right here. Deactivate this. Activate the stress. Yeah, that is 200,000 psi. So that is pushing it close to the uh, yield strength. Obviously, it depends what kind of a steel you've got. If it's structural steel, let me let me write the Young's modulus one more time. 30 million psi, and I knocked down. Yeah. So wow, this actually I made a mistake here. If you take 30 million as the Young's modulus of steel and knock down three zeros, you get 30,000 psi. I said 300,000 is yield strength. So of the order of magnitude 30,000 psi, and this is almost 8 times bigger. Definitely, this will, in all likelihood, unless it's a very unusual situation, very special type of heat-treated steel, this will definitely yield. Structural steel, Young's or the yield strength for structural steel is about 30,000 psi. This is 8 times bigger. Yep. Anyway, that takes care of the second activity.